AP Calculus BC and 5-day 7 warm-up. And then I also plan to do an example of a problem that could be helpful for the day 6 homework and future assignments on a subpage. So try these problems out and pause the video until you have, and then I will show you how to do them. Okay, first one. Please don't make it complicated. U equals x squared, du equals 2x dx. This is just plain old substitution. Some of you guys are probably trying to do like integration by parts on this. It's going to be 1/2 sine u du. It's going to be -1/2 cosine u plus c. Final answer is going to be -1/2 cosine of x squared plus c. Done. So the lesson here is don't make them all hard. Okay? Next test is going to have all of these kind of problems all mixed up together. So try easy approaches first. Next one. U-substitution is not going to work. I don't think. No. But consider it. Can't do partial fractions. We're going to have to do long division because the degree of the top is equal or greater than the bottom. So U-sub doesn't work. Can't do partial fractions yet. So we're going to do long division. Okay. So it's going to be x cubed minus 6x squared plus 8x plus 1 x squared minus 6x plus 8. Focus on the first one, so that's going to be x. Distribute x cubed minus 6x squared plus 8x. I'm going to subtract it. Everything cancels out. Get 0, drop the next number down, plus 1. That is your remainder. So what we have now is we have the integral of x plus the remainder over the original denominator. Now, you got to try and integrate that, and we can't. This is where we should do partial fractions. X minus 2, x minus 4. You have to do partial fractions. It's going to equal a over x minus 2 plus b over x minus 4. Multiply through by the least common denominator, you get 1 equals a x minus 4 plus b x minus 2. You can get rid of either one first. It's up to you. I'll give you 1 equals -2a. A equals -1/2. You plug 4 in. 1 equals 2b. B equals 1/2. So I think we're getting close. I'm going to rewrite it. I'm going to break this up. X dx minus 1/2 dx over x minus 2 plus 1/2 dx over x minus 4. I'm going to integrate each one. X squared over 2 minus 1/2 natural log of the absolute value of x minus 2 plus 1/2 natural log of the absolute value of x minus 4 plus c. Now this is an answer, but I want to use log rules to combine the logs together. If we do that, we could just put the 1/2 because they both have 1/2. So we just factor 1/2 out. Natural log of that one's gonna be on top. This one's gonna be in the bottom division. It's gonna be x minus 4 over x minus 2. You could just put them in one absolute value plus c. Or you could bring the 1/2 inside now or before this step, and it would be natural log of the square root of the absolute value of x minus 4 over x minus 2 plus c. So some different ones. Now at this point, if we were in class, I would go over the homework except for the last 2 problems from yesterday's assignment, day 6. Before we do those, I wanted to give you guys an example I ended up already doing it in the last video, but I was looking for it. I had a hard time finding it. But I want to do one example. So this is like notes. You could put this on the back of your warm up or whatever. I want to do a problem like this: e to the x sine x dx. I guarantee you're going to get something like this in your next test. You're going to need to practice these. These are a little tough. Now, we can't integrate this the way it is with any other strategies. We have to use integration by parts. So, flip it. This is expo. This is trig. So we got expo and trig. There's no shortcut. Shortcut's got to be poly-expo, poly-trig. Whatever's first on the list is your u. Next one is b prime. So u equals e to the x. B prime equals sine x dx. We're going to take the derivative of this. It's going to be e to the x. We're going to integrate this. It's going to be negative cosine x. This should have a dx now. So when we write it, it's going to be uv, negative e to the x cosine x, minus the integral of these two new things together. There's an extra negative, e to the x cosine x dx becomes plus plus. And usually, hopefully, what happens is we get something in this interval that we can actually do using a different technique. But sometimes you don't. Sometimes you got to do it again. Okay, let's do it again. We have expo, we got trig, we got expo and trig again. So this is going to be our u. It's going to be b prime. So this is a new u equals e to the x, b prime equals cosine x dx. So u prime equals e to the x dx. This guy you're going to integrate and get b equals sine x. So if we rewrite this, it's going to be e to the negative x cosine x plus parentheses e to the x sine x uv minus the integral of the two new parts e to the x sine x dx. Oh my gosh, but we can't do that. I feel like we're going in circles. And we are. It's never going to end. But check this out. If in this situation, if you can get this to match this, we're going to use a little trick. We're going to move this to the other side and combine it with that guy. So we're going to add integral e to the x sine x dx to both sides. So this is kind of slick way of dealing with this. So you're going to actually have two e to the x sine x dx's on the left-hand side. And negative e to the x cosine x plus e to the x sine x. And I guess we put a plus c now. But now this is the thing we're trying to find, right? So let's just divide by 2 and that should be our answer. So e to the x sine x dx equals negative 1/2 e to the x cosine x plus 1/2 e to the x sine x plus c. Don't write 1/2 c. Don't write c over 2. Just write c. It's just a constant. So that's how we do those. So I would try problem 9 and 10 from yesterday's last assignment on your own now. Make sure you can actually get these right. Ooh, I was trying to finish before I sneezed, but I couldn't. Anyways, try these 9 and 10 on the previous assignment. They're going to come up again, and I guarantee I'm going to give you one like this on your next test. So make sure you get the process. I mean, once you figure it out, it's kind of predictable. We kind of know what we're going to do. You got to be super careful, though, with distribution and stuff. There's lots of little mistakes that are easy to make. All right. That's it for today's warm-up and notes. So you're going to try today's assignment, 5-7, and get some more practice with these.